Hello viewers, welcome to A Chemistry. Dear viewers, this video is on MCQ of VSEPR Theory, how to predict the shape and geometry of molecules. As you know, a couple of questions always asked in IIT JAM GATE and NET examinations regarding the geometry of molecules. So this video we are not going to discuss much about the theory, but only I will discuss how to predict the shape of molecules, their hybridizations and number of bond pair of electrons and lone pair of electrons present in that molecule. So without wasting time, let's start the video. So how will solve these questions? These questions asked in JAM 2020. Also, these questions also asked in GATE 2021 regarding the shape of molecules. Also, these questions again asked in NET 2017 December. So, are you going to mug up or remember the shape of all these molecules? No, not at all. You don't worry, I will give you a trick how to predict the shape and geometry of all these molecules. I am sure after watching this video, you can solve all the questions regarding VSEPR theory. So, to predict the shape of molecules, it is very necessary to know the total pair of electrons present in that molecule. So, total number of pair of electrons is equal to number of bond pairs plus number of lone pairs. As you know, according to VSEPR theory, to predict the shape of molecules, lone pair of lone pair repulsion is much more greater than lone pair bond pair repulsion is greater than bond pair repulsion. That is the reason how the molecules shows different structures or different geometry or shape. So as you know, the total pair of electrons is equal to bond pair of electrons plus lone pair of electrons, and bond pair of electrons totally depends upon the number of surrounding atom. That number of surrounding atom can be one or can be different types of. So here capital N bracket N1 N2 means that can be different atoms. Okay, and lone pair of electrons is nothing but half bracket M. This capital N stands for the outermost electrons present at in central atom. Central one molecule will be there. That central atom, number of outermost electron present in central atom is the N, minus bracket number of surrounding atom into valency of surrounding atom. Valence of chlorine will be there, valence 1. If a chlorine is 4 chlorine surrounded by central atom, then 4 into 1. So this part bond pair depends upon the surrounding atoms, lone pair depends upon this another part. So combinedly bond pair and number of bond pairs and number of lone pairs of electrons will predict the shape of molecules. This formula is for neutral molecules. Suppose we have charge species, suppose CO3 2 minus carbonate ion is there, sulfate ion, NO3 minus is there. All the formula is same, only this plus minus y. If plus charge will be there, then plus y, minus y. If a negative charge is there, plus y. If a minus charge is there, then plus y. Okay. For charge species, suppose carbonate 2 plus is there, CO3 2 minus is there, SO4 2 minus is there, NO2 minus is there, NH4 plus is there. For charge species, how will predict the shape of that charge specific? All the formula is same. Only in the last part is in the lone pair plot. This plus minus y means if we have a negative charge, then we will add that charge. If there is a positive charge, then we will subtract the charge. So y the charge of ions, for positive charge minus y, for negative charge plus y. So this formula, to know the number of bond pairs and the number of lone pairs present in that neutral molecule or charge species. Okay, then these things you have to calculate the number of bond pair and number of lone pair. Then another table you have to remember. So if we have total number of pair of electrons 2, then regular geometry will be linear. If the total pair of electron is 3, then that is trigonal planar. If total pair of electrons is 4, then that will be tetrahedral, regular. I am talking about the regular geometry. If 5, that is trigonal bipyramidal, is 6, that is octahedral, is 7, then that is pentagonal bipyramidal. So for that, suppose that is the bond pair, lone pair electrons. This is the table you have to remember always to predict the shape of molecules. After calculating the number of bond pair, lone pair, this table you have to remember. Suppose 2 bond pairs are there, 0 lone pair, then the geometry will be linear. If total pair of electrons 3, then bond pair possibility 3, lone pair possibility 0, then that will be trigonal planar. If 2 bond pairs are there, 1 lone pair is there, then this is angular. Suppose we have total pair of electron 4, that can be 4 0, that can be 3 1, that can be 2 2. If 4 0 is there, then this is regular tetrahedral. If 3 bond pairs is there, 1 lone pair is there, then that will be trigonal pyramidal structure. If 2 bond pairs, 2 lone pairs is there, then that will be band structure. If out of 5 bond pair of electrons, bond pair 5, 0 lone pair, trigonal bipyramidal. If 4 bond pair, 1 lone pair is there, then that will be seesaw. Similarly, if 3 bond pair, 2 lone pair is there, then that will be T-shape, bent T-shape. If 2 bond pair, 3 lone pair is there, that will be linear. Similarly, suppose 6 total pair of electron is 6, then that will be 6 bond pair, 0 lone pair, that will be octahedral geometry. If that 6 pair of electrons will divide into 5 bond pair, 1 lone pair, that will be square pyramidal. If the 4 bond pair, 2 lone pair, that is square planar. If total pair of electron is 7, then if 1 pair is 7, lone pair is 0, that will be pentagonal bipyramidal. If a bond pair 6, lone pair 1, then that will be pentagonal pyramidal. If 5 bond pairs are there and 2 lone pairs are there, then that will be pentagonal planar. After calculating the number of bond pair and lone pair of electrons, you will go to the table, then you will predict the shape corresponding to the number of bond pair and lone pairs. So let us discuss some examples regarding this. So first we will discuss about beryllium chloride. So here beryllium is the central atom and 2 chlorines are surrounded. So bond pair, total numbers of surrounding atom 2 plus half 2 is the beryllium outermost electron present in beryllium 2 minus 2 is the number of surrounding atom, that is chlorine is the total number of chlorine surrounded 2 into valency of chlorine 1. So totally you will get 2 bond pair, 0 lone pair. The shape of the molecule will be linear. So in the table we will predict the shape of the molecule. If you will go to the another structure, that is carbon dioxide. So carbon is the central atom, 2 oxygens are surrounded. So total number of pair of electrons will be 2 plus 2 surrounding 2 oxygen surrounded 2 carbon. So 2 is the number of surrounding atom plus half. This 4 is nothing but outermost electron present in carbon. So carbon outermost electron is 4 minus 2 number of surrounding atom 2 into valency of oxygen is 2. So 2 plus 0, boiling bond pair 2 and lone pair 0. The shape of the molecule will be linear, carbon dioxide linear. If we go to another shape of molecule BF3, here 3 fluorine atoms surrounded boron. So boron is the central atom and 3 fluorines are surrounded. So number of pair of electrons is equal to number of bond pair. Bond pair is the total number of surrounding atom 3 plus half. This 3 is the central atom here boron. How many outermost electron present in boron? 3 minus bracket 3 number of surrounding atom into valency of fluorine is 1. So 3 plus 0, bond pair 3 and lone pair 0. So that the shape will be trigonal planar. Okay, the shape will be trigonal planar. So in this way you have to predict the shape of molecule. First you have to predict which one is the central atom and what are the surrounding atoms present. Number of surrounding atom is equal to number of bond pair of electrons. Half bracket start, then which one is the central atom? Here is the beryllium, carbon, boron. So outermost electron of that's outermost, I am talking about the outermost electron. Carbon total atomic number 6, 2 plus 4. So 4 is the outermost electron of carbon. Similarly 3 is the outermost electron of boron and 2 is the outermost electron of beryllium. By using same formula also we can predict the shape of methane molecules. So in methane formula is CH4, total number of surrounding atom 4 hydrogen surrounded to carbon. So 4 is the total surrounding atoms, that is the number of bond pairs, half bracket. Carbon is the central atom, so outermost electron of carbon is 4 minus 4 is the surrounding atom into 1 is the valency of hydrogen. So by using this formula we will get a total bond pair 4 and total lone pair 0. So 4 bond pair, 0 lone pair, the shape of methyl will be tetrahedral. So by using the formula and remembering the table, we can predict the shape of all the molecules. Similarly, let's see other examples. In case of ammonia, so number of bond pair is 3. Nitrogen is the central atom. So outermost electron of nitrogen 5. 3 into 1, number of surrounding 3. Into 1 is the valency of hydrogen. So 3 bond pair, 1 lone pair will get. So the shape of ammonia will be pyramidal, trigonal pyramidal. Similarly, if we'll go to OF2, the total number of pair of electrons will calculate, and that will be 2 bond pair and 2 lone pair by using the same formula. Here 6 is nothing but outermost electron of oxygen. Here the central atom is the oxygen. So 2 bond pair, 2 lone pair, the geometry will be bent or V shape. If you remember the table given before slide. So similarly, we can predict the shape of water also. In case of water, we will get 2 bond pair and 2 lone pair of electron, and the shape will be bent or V shape. So similarly, also we can predict the shape of H2S molecule. Okay. So in this way, you have to predict the shape of all these neutral molecules. In case of H2S, similar as H2O, here the two surrounding atoms are hydrogen, sulfur is the central atom. So outermost electron of sulfur is 6. So two surrounding atom, 2 into 1, 1 is the hydrogen valency of hydrogen. Here, to predict the shape of molecule, you have to always remember number of bond pair and lone pair corresponding to structure. So if number of bond pair 2 and number of lone pair is 2, then the shape of the molecule will be bent. So you have to remember this previous table. This table you have to remember number after calculating the number of bond pairs and number of lone pairs. Then you will find out the corresponding geometry of that molecules. So this table you have to always remember this table. Number of bond pair, number of lone pairs correspond to which geometry. Okay. Listen, let us discuss another molecule PCl5. 5 surrounding atom, half 5 is the phosphorus under the nitrogen. So number of outermost electron of phosphorus 5 minus 5 into 1. 1 is the number of surrounding atom 1. 5 number of 5, 1 is the chlorine valency of chlorine. So 5 plus 0 bond pair 5, 0 lone pair 5, and the shape of PCl5 will be trigonal bipyramidal. So similarly, if you look the shape of PF3, then the total bond pair will be 3 and total lone pair will be 1. So 3 plus 1, the shape of the molecule will be pyramidal. Similarly, if you look at the structure of ClF3, then we'll get, by using same formula, we'll get total bond pair 3, total lone pair 2, and the shape of molecular will be trigonal planar. So shape of the molecule will be trigonal planar. If we look at the shape of IF7, the 7 is total surrounding atom, half iodine, the central atom of atom is iodine, and the outermost electron always for halogen is 7. 7 minus 7 into 1. 1 is the valency of phosphorus, so we'll get 7 plus 0, 7 bond pair, 0 lone pair, and the shape will be pentagonal bipyramidal. Similarly, if we'll go to the shape of SF6, so total surrounding atom 6, and sulfur is the central atom, so outermost electron of sulfur is 6. 6 into 1, valency of fluorine is 1. So 6 plus 0, if 6 is the regular geometry, then will be octahedral shape. Then we will look at the shape of SF4. So we'll get a 4 bond pair, 1 lone pair, that is 5. So the shape will be seesaw. The shape is seesaw for 4 bond pair and 1 lone pair of electrons. For sulfur dioxide, the total bond pair to 2 oxygen surrounded sulfur. So half this is the outermost electron of sulfur, 2 into 2 is the valency of oxygen, so we'll get 2 plus 1, 3, and that will be angular shape. 2 bond pair, 1 lone pair, the shape will be angular. Then, if you look at the shape of xenon compounds, xenon F2. So, in xenon F2, 2 is the surrounding atom and fluorine 2 surrounding fluorine surrounded xenon. So, xenon is the central atom. The outermost electron of xenon is 8. So 2 surrounding atom into 1 fluorine, atomic number of fluorine. So we'll get a 2 plus 3, total bond pair 3, and 3 is the lone pair of electron. So we'll get the shape of xenon F2 linear. Similarly, if we'll go to the shape of xenon F4, so we'll get a 4 bond pair, 2 lone pair of electron, total 6. The shape of xenon F4 will be square planar. If in the table, if you go to, if you have remember the table, then 4 bond pair, 2 lone pair, the shape will be square planar. If we go to xenon F6, in case of xenon F6, here xenon is the central atom. The outermost electron of xenon is 8. So 6 into 1 means 6 is the total surrounding and 1 is the valency of fluorine. So we'll get 6 bond pair, 1 lone pair of electron, total 7. If 6 bond pair, 1 lone pair, if you remember the table, the shape of will be pentagonal pyramidal. Xenon F6 shape will be pentagonal pyramidal. Then if you look at the xenon O3 shape, the total pair of electrons will be 4. 3 oxygen surrounded the xenon atom. So xenon is the central atom and 3 oxygen surrounded the xenon. So number of pair of electrons 3. Bond pair 3, half, 8 minus 3 into 2. So we'll get 3 bond pair and 1 lone pair. So 4 is the total pair of electrons. So 3 bond pair, 1 lone pair. The shape will be trigonal pyramidal. Okay. So till now we have discussed the molecules, simple molecules having one type of central atom, one type of surrounding atom. So in this case, xenon OF6, here xenon is the central atom and oxygen, 1 oxygen, 6 fluorine are the surrounding atom. So how many surrounding atoms? 6 fluorine, 1 oxygen. Total surrounding atom 7. So total bond pair of electrons will be 7. Then half bracket 8. 8 is the 8 is the outermost electron of xenon, central atom, minus, so surrounding atom 6 fluorine, 6 into 1 valency of fluorine. Again you have to subtract how many surrounding atom? Oxygen, 1 oxygen surrounding atom, 1 into valency of oxygen 2. So in this way we will get 7 bond pair of electron, 0 lone pair of electron. The shape will be pentagonal bipyramidal. So in this case, more than one type of surrounding atom, you have to take account of all the surrounding atom. So you have, in case of lone pair, calculation of lone pair of electron, you have to subtract all the factors of surrounding atom. So similarly, if you consider the structure of xenon OF4, so total surrounding atom 4 fluorine, 1 oxygen, total 5 surrounding atom. So total bond pair of electrons 5. So xenon is the central atom. So outermost electron of xenon is 8 minus 4 into 1, 4 surrounding atom 4 fluorine into 1 valency of oxygen minus 1 to surrounding oxygen is the only surrounding atom. 1 surrounding atom of oxygen, 1 into 2 is the valency of oxygen. So we'll get a 5 bond pair, 1 lone pair. So the shape will be square pyramidal. The shape will be square pyramidal. Similarly, if you consider the structure of xenon O2F2, total surrounding atom 2 oxygen 2 fluorine, so total surrounding atom will be 4 and the total bond pair of electron will be 4. Then half 8, this xenon is the central atom, so the outermost electron xenon 8 minus, for oxygen, for fluorine you have to subtract separately, minus 2 is the fluorine, total number of fluorine 2 into valency of fluorine 1 minus total oxygen 2 into valency oxygen 2. So finally we'll get a 4 bond pair, 1 lone pair of electron 5, 4, the shape will be seesaw. 4 bond pair, 1 lone pair, the shape will be seesaw. Now let us discuss about the charge species. Suppose we have carbonate and CO3 2 minus. Here 2 minus is the charge, negative charge is there. So total surrounding atom 3 oxygen, 3 plus half 4 is the outermost electron of central atom, here is the carbon, minus 3 into 2, 3 is the total oxygen into 2 is the valency of oxygen. Here in this green representation, see at the green representation we have 2 minus, so we have to add plus 2, not subtract 2. So we have to add plus 2. So this fragment will be total number of lone pair. So we'll get a 3 bond pair, 0 lone pair from this calculation. So the shape will be trigonal planar. Similarly, if you look at the structure of NO3 minus, so 3 is the total oxygen, here 5 is the outermost electron of nitrogen, minus 3 into 2 total oxygen 3 into valency of oxygen 2, here plus 1 because minus is there, so we have to add plus 1. So we'll get 3 bond pair, 0 lone pair, the shape will be again trigonal planar. So if you look at the structure of ClO3 minus, so here we'll get, here plus 1 will be there, we'll get a 3 bond pair, 1 lone pair. The shape will be trigonal pyramidal. Similarly, if you look at the structure of I4 plus 1, so here plus charge is there, so here minus 1 will subtract. So iodine is the central atom, 4 fluorine are the surrounding atoms. So by using the formula, we'll calculate, we'll get the total bond pair 4 and total lone pair 1. So the shape will be seesaw. Similarly, if you look at the shape of SO4 to sulfate ion, here sulfur is the central atom and 4 oxygen surrounded the central atom sulfur. So by calculating, we'll get a 4 bond pair and 0 lone pair. So the shape will be tetrahedral. Similarly, if you look at the structure of chlorate ion ClO4 minus 1, similarly we'll get a 4 bond pair, 0 lone pair. The shape will be again tetrahedral. If you look at the shape of NH4 plus ammonium ion, here plus 1 charge is there. In the calculation, we are subtracting minus 1. So same process, total surrounding atom 4, nitrogen is the central atom, outermost electron 5, minus 4 total surrounding atom into valency of hydrogen 1 and again minus 1. So we'll get 4 bond pair, 0 lone pair. The shape will be tetrahedral. So in this way, we can calculate the shape of charge species by using the formula, and after getting the total bond pair and lone pair, you will go to the table and corresponding to total number of bond pair lone pair, you will get the shape of the molecule. Now we are going to discuss about the previous year questions. So these questions asked in JAM 2020 regarding the shape of molecules. The geometry of species Br3 plus, Br3 minus, Brf3 are respectively. So here linear, trigonal, biparent, trigonal. So regular geometry is asking. So here to solve this type of question, let us discuss Br3 plus. Here to know the central atom, you have to break Br3 into Br and Br2. Listen, in this way, so Br will be central atom and 2 Br2 will surround the 1 bromine atom. So the total bond pair will be 2 and total lone pair will be 2. So total number of pair of electron will be 4 and the regular geometry will be tetrahedral. Similarly, if we will discuss about Br3 minus, so total bond pair will be 2 and total lone pair will be 3 and total pair of electron will be 5 and the shape will be trigonal bipyramidal. Similarly, if we will discuss about Brf3, then we will get the total bond pair of electron 3 and total lone pair of 2 and total pair of electron will 5 and again the shape will be trigonal bipyramidal. So one will be tetrahedral, another will be trigonal bipyramidal and again trigonal bipyramidal. So what will be our answer? The answer will be C. C is the correct answer. Next, another question. Consider the following 4 xenon compounds: xenon F2, xenon F4, xenon F6, xenon O3. The pair of xenon compounds expected to have non-zero dipole moments means the shape of molecule which have non-zero dipole means dipole moment cannot be zero. So we have 4 pairs of xenon compounds. So listen, xenon F, what are the shape of the, first you have to predict the shape of these molecules. So listen, xenon F2 shape is linear, xenon F4 shape is always square planar, xenon F6 that is pentagonal pyramidal, and what about xenon O3 that is trigonal pyramidal. So in case of xenon F2, xenon F4, fluorine is highly electronegativity atom, that's why the dipole moment will cancel with each other in case of xenon F2 and xenon F4. But in case of xenon F6 and xenon O3, as fluorine and oxygen are more electronegativity, so the dipole moment will not cancel, will get some resultant dipole moment. But in case of xenon F2, xenon F4, as dipole moment is a vector quantity, so the dipole moment will cancel with each other. We will get zero dipole moment in case of xenon F2 and xenon F4. So the answer will be in case of xenon F6, xenon O3. So answer is D. So how will predict the shape of molecule? So we have a reference like before. So in this way, by using the previous formula, we will get the shape of xenon compounds, calculating number of bond pairs and number of lone pair of electrons. Then you will go to the respective table. The corresponding shape will be the shape of the relative molecules. Then coming to the next question, among the following species having seesaw shape is R. That means more than one answer are possible. So we have molecule SF4, xenon F4, Cl4 plus Cl F4 minus. So by using same formula, we have to calculate the number of bond pair, lone pair of electrons. So here in case of SF4, we'll get a 4 bond pair, 1 lone pair. The shape will be seesaw. So here we'll get one seesaw. Again, if you look at the structure of xenon F4, we'll get 4 bond pair, 2 lone pair. So the shape is square planar. So in case of ClF4 plus, we'll get 4 bond pair and 1 lone pair of electrons. The shape is seesaw. Again, in case of ClF4 minus, we'll get 4 bond pair, 2 lone pair. The shape is again square planar. So in two cases, SF4, ClF4 plus, we'll get seesaw shape, and the answer will be A and C. The answer is nothing but A and C. Another question, the species having trigonal pyramidal shape. This question asked in JAM 2015. So all three species are ionic species, one is neutral. So by using same methodology, you will get number of bond pair and lone pairs. A carbonate ion, 3 bond pair, 0 lone pair. This is trigonal planar. NO3 minus, that is also 3 bond pair, 0 lone pair, trigonal planar. In case of BrF3, 3 bond pair, 2 lone pair, that is simple T shape. Okay, that is T shape. In case of SO3 2 minus sulfite ion, so 3 bond pair, 1 lone pair. So the shape is pyramidal, trigonal pyramidal. So the answer is trigonal pyramidal shape SO3 2 minus. So answer is D. So in this way, we will solve this problem to predict the shape of molecules. So moving to the next question, predict the geometry of tellurium tetrafluoride by VSEPR theory. Listen, tellurium present in oxygen family, oxygen, sulfur, tellurium. So let's this central atom is the tellurium, 4 oxygen are the surrounding atom. So by using the formula, we will get 4 bond pair, 1 lone pair. Here is central outermost electron of central atom 6, as it is present on oxygen family. So we'll get 4 bond pair, 1 lone pair. The shape is nothing but regular shape is given. So we'll get 5 is the regular total pair of electron. So we'll get trigonal bipyramidal. So the answer is D. D is the answer. Okay. So moving to the next question. What is the molecular shape of SOCl2, thionyl chloride? So we have the option given square planar, trigonal pyramidal T shape. So similarly, we have to calculate the number of bond pair, lone pair of electrons. Here two types of surrounding atoms are there. Oxygen is one surrounding atom. Two chlorines are another two surrounding atom. So total surrounding atom will be 2 plus 1, 3. 3 bond pair of electrons have sulfur like oxygen outermost electron of sulfur 6 minus 2 chlorine 2 into 1 minus 1 oxygen 1 into 2 valence oxygen 2 will get 3 bond pair 1 lone pair of electrons. So 4 is the total pair of electrons. So we'll get 3 bond pair 1 lone pair. So we'll get trigonal pyramidal. So answer is B. B is the answer. Next question is, which of the following has square planar geometry to the VSEPR theory? So we have xenon O2F2 SF4 BF4 minus xenon F4. So by using the same formula, so in case of xenon O2F2, we have 4 bond pair, 1 lone pair. So total 5 and the shape is seesaw. So in case of SF4, we have 4 bond pair, 1 lone pair. So that is also seesaw. So in case of BF4 minus, so plus 1 is there, BF4 minus 4 bond pair, 1 lone pair. Again this is seesaw. In case of xenon F4, so we'll get a 4 bond pair, 2 lone pair. So it is square planar. So by using the formula and the table given before, we will get the shape of molecules. So here answer is D. So moving to the next question, V shape of sulfur dioxide is due to presence of what? So here shape is given, sulfur dioxide shape V shape or band shape. How many sigma bond, pi bonds and lone pairs are there? Listen, let us discuss the shape of sulfur dioxide. So if we will discuss the total pair of electron of sulfur dioxide, 2 bond pair, 1 lone pair. So 2 bond pair means 2 sigma bonds are there, 1 lone pair is there. So here 2 sigma, 1 lone pair of electrons. So the answer of sulfur dioxide, V shape of sulfur dioxide is due to 2 sigma and 1 lone pair. So the answer is C. Okay, that is angular sum. So moving to the next question, shape of CS3 minus, this is carbanion, methyl carbanion, is trigonal pyramidal, tetrahedral, trigonal pyramidal, linear. So similarly, ionic species like ionic species will predict the shape of molecule by using the formula. Will get the total bond pair 3 and lone pair 1. So 3 bond pair, 1 lone pair. The shape will be trigonal pyramidal. Okay, the answer is C. So by using the table and the calculation of bond pair, lone pair of electron, you can predict the shape of all type of molecules. Okay, coming to another question, this question asked in GATE 2021. So the shape of the compound ClF3, xenon OF2, N3 minus, xenon O3, AF2. Same process. All the shapes are given in the choice. So first we'll discuss about ClF3. So by calculating the total bond pair, lone pair. So 3 bond pair, 2 lone pair. The shape of ClF3 is a trigonal T shape. Okay. Then considering the shape of xenon OF2, so we'll get a 3 bond pair, 2 lone pair. The shape is again T shape. Okay. Then if you considering n3 minus, here in case of n3 minus, we have to segregate n and n2 minus. So central atom will be one nitrogen atom and two nitrogen will be the surrounding atom. So we'll get two bond pair, zero lone pair. Then the shape is nothing but linear. Then if you consider about xenon O3F2, the similarly by using the formula we will get a 5 bond pair, 0 lone pair of electron. Then the shape is trigonal bipyramidal. Shape is trigonal bipyramidal. So these are the shape of four molecules and the option is matching T shape, linear, trigonal, bipyramidal. So answer is the A is the correct answer. So in this way, you have to solve the questions regarding VSEPR theory. Very, very easy. So moving to the next question, among the following species, the one that has pentagonal shape, which molecule has pentagonal shape? Xenon O4, OF4, IF5, SF5 minus, xenon F5 minus. So by using the same formula, if you calculate xenon OF4, so 5 bond pairs, 1 lone pair. The shape is square pyramidal. If you go to the IF5, the total bond pair 5, 1 lone pair, the shape of IF5 will be square pyramidal. Again, if you will go to the SF5 minus, so you will get a 5 bond pair, 1 lone pair. So again the shape is square pyramidal. If you go to the xenon F5 minus, so here we will get 5 bond pair, 2 lone pair. So in this case you will get a trigonal planar structure. Sorry, pentagonal planar structure. So in this case only we will get a pentagonal shape. Okay. So the answer is D. D is the correct answer. So by using the VSEPR theory, calculating the number of bond pair, lone pair of electrons and referring the concerning table, you will get the shape of molecules. So moving to the next question, shape of xenon F5 plus, xenon F5 minus respectively. Very, very simple. You will calculate xenon F5 plus. So how many bond pair? 5 bond pair, 1 lone pair of electrons. The shape is nothing but square pyramidal. If you go to the structure of xenon F5 minus, so you'll get a 5 bond pair, 2 lone pair. The shape is pentagonal planar. So the option is nothing but D. D is the correct answer for these questions. So moving to the next question. According to VSEPR theory, shape of SF2Cl plus and S2O4 minus. This is thionate ion. So in case of SF2Cl plus, 3 bond pair, 1 lone pair. We'll get 3 bond pair and 1 lone pair. So the shape is trigonal pyramidal. But in case of thionate ion, here more than one central atom there. For that, this is a combination of two molecule and this is a linked compound. So in this case, we have to see actual structure of the compound. So this is the structure of thionate ion. So in this case we will get a 2 bond pair and 1 lone pair of sulfur from the Lewis structure. So if we have 3 bond pair, 1 lone pair, the shape is nothing but trigonal pyramidal. So in both cases we will get trigonal pyramidal shape and the answer is D. So this is the answer of this question. So moving to the next question. According VSEPR model, the shape of xenon O5 minus is very simple. You calculate the shape of xenon OF5 minus. 1 oxygen, 5 fluorine atoms are the surrounding atom, minus is the charge. So total bond pair of electrons 6. 8 minus 5 into 1, 1 into 2 plus 1 for minus charge. So we'll get 6 bond pair, 1 lone pair. So the shape will be pentagonal pyramidal, same as monopyramidal. The answer is D. So in this way we can predict the shape of molecule by calculating the number of bond pairs and lone pair of electrons. So coming to the next question, among the following the isoelectronic and isostructural pair is, so here which pair is isoelectronic as well as isostructural, means two molecules, a pair of molecules, same shape and same number of electrons. Isoelectronic means number of electron will be same and the shape will be same. Which pair? So let us consider all the shape of all the molecules. So here carbon dioxide linear, 2 bond pair, 0 lone pair. Sulfur dioxide angular, sulfur trioxide trigonal planar, selenium trioxide trigonal planar, tellurium oxygen, selenium and oxygen, sulfur, selenium, tellurium, all are in one family. So outermost electron of central atom is always 6. So nitrogen, phosphorus in one family. So NO2 plus linear. Here silicon present in carbon family, same as carbon, number of outermost electron 4. So we'll get tetrahedral SiO4 4 minus, PO4 phosphate ion, we'll get tetrahedral. So here two pairs, sulfur trioxide and selenium trioxide, both are same shape, trigonal planar. But in case of SiO4 4 minus and PO4 3 minus, same structure. But in case of SO3 and SeO3, total number of electrons 40 and 58. Why sulfur? The atomic number 16, 3 oxygen 24, total 40. Selenium, the atomic number 34 plus 24 for 3 oxygen, so we'll get 58. So both are different, 40 and 58. So these two are not isoelectronic. But if you look at the SiO4 minus and PO4 3 minus, so we'll get 50 electrons each. Where silicon, the atomic number 14 plus for 4 oxygen 32, and here 4 minus is the charge, so we have to add 4 here. So for PO4 phosphorus 15 plus 8 into 4 32, and we have to add plus 3 here for 3 minus charge, so we'll get 50. So in case of SiO4 4 minus and PO4 3 minus, we'll get both isoelectronic and isostructural. So correct answer is the D. D is the correct answer. So coming to the next question, the pair of compounds having the same hybridization for the central atom. Here hybridization asking. Listen, how after getting the number of pair of electrons, we can say the what will be the hybridization of central atom. Listen, if you look at the structure of xenon F4 SiF6 2 minus, So total number of pair of electrons, if total number of pair of electrons 2, then that is sp hybridized. If 3, that is sp2. If 4, that is sp3. If 5, then that is sp3d. If 6, sp3d2, like this. Here in case of xenon f4, we are getting total pair of electrons 6, so that is sp3d2. In case of SiF6 2 minus, we are getting total pair of electrons 6, so that's why the hybridization is sp3d2. So in case of nickel tetrachloronickel 2 minus, this hybridization will get from valence bond theory. So we are not going to discuss the hybridization of these molecules, complex molecules. You can study in your textbook. So in case of NiCl4 2 minus and tetrachloroplatinate 2 minus, so here hybridization sp3 and dsp2 square planar geometry in case of platinum. In case of tetracarbon in nickel, the hybridization is sp3. But in case of xenon O2F2, according to VSEPR theory, will get total pair of electron 5. So the hybridization will be obviously sp3d. So in case of these two cobalt hexaamino cobalt complex 3 plus and hexaaquo cobalt 3 plus, will get hybridization from the VBT D2 sp3 and sp3d2. Okay. So these are hybridization. Suppose to 1s 1p, that is 2. Total pair of electrons is equal to total number of orbitals taking part. Okay. So if 2 sp, if 3 sp2, if 4 sp3, likewise. So sp3 tetrahedral can be tetrahedral, can be square planar. Okay. So if we are going to discuss about all the molecules, so please look at these molecules, in which case we will get the same compounds having same hybridization. In which case, in case A, we are getting same hybridization sp3d2. So answer is the A. A is the correct answer. So in this way, if you will get the total pair of electrons, so indirectly you will get the hybridization of central atom. Okay. Next, moving to the next question. This question asked in NET 2022. This question organized by National Testing Agency. So what are the among the following, which set of molecular or ionic species all have planar structure? In which pair of compound having the planar structure? All have planar structure. Listen, what are the molecules? BrF3, FClO2, xenon F5 minus, also ClF4 minus, FCl2, xenon O3 there. Let us discuss the shape of all these molecules, then we will get the answer very quickly. Listen, these are the shape of all the molecules given in the choice. BrF3, that is trigonal planar having 3 bond pair, 2 lone pair. FCl2, 3 bond pair, 1 lone pair, that is trigonal bipyramidal. Xenon F5 minus will get pentagonal planar. Xenon O3, we are getting trigonal pyramidal. ClF4 minus, we are getting square planar. So question asked, which set of molecular ionic species all have the planar? Listen, trigonal planar, here pentagonal planar, square planar. That is mean BrF3, xenon F5, BrF3, xenon F5, ClF4 minus, ClF4 minus, FCl2. Okay, answer 2 is the correct answer. Listen, look at the option 2. These are all three: xenon O3, ClF4 minus, FClO2 all have the planar structure. Planar in a trigonal, one case trigonal planar, another is pentagonal planar, another is square planar. So answer 3 is the correct answer. 3 is the correct answer. ClO4 minus, xenon F5 minus, and BrF3 minus. Okay, so this is the correct answer. Answer 3 is the correct answer. So these three structures are planar. Next question is again from NET 2020. As per VSEPR theory, shape of SO3 2 minus, CO3 2 minus, BrF4 minus R. So these are the shape of ionic species. So by using the formula, you can calculate number of bond pair and lone pair of electrons, and from the bond pair and lone pair of electrons we will predict the shape. So let us discuss. So these are the number of bond pair of lone pairs of electrons of SO3 2 minus, 3 bond pair, 1 lone pair. Shape is trigonal pyramidal. For CO3 2 minus, 3 bond pair, 0 lone pair. So this is trigonal planar. In case of BrF4 minus, so 4 bond pair, 2 lone pair. So this is square planar. By using previous calculations, so what will be your answer? Trigonal pyramidal, trigonal planar, and square planar. So third one is our answer. 3 is our answer. So moving to the next questions. Match the appropriate geometry on the right with each other species on the left. So this is a matching type of question. Correspond to which shape molecule is given in A and the shape is given in column B. So as you know, xenon O3 is a pyramidal shape and xenon OF2 is T shape, trigonal pyramidal. So xenon OF2 is T shape. So if we will talk about this larger molecule F xenon OF2, so this can be justified in their structure. So xenon F xenon OSO2F, this is a linked compound. So this is linear, having sp3 hybridization, sp3d hybridization. F xenon NSO2F2. So structure is again, this structure is linear. So which answer is same for A and B? Linear is the answer. So for A I, for B is also I, for C that is 2I, and for D that is T shape 3. So option number 1 is the correct answer. Okay. So moving to the next question. In compound N3P3F6, the geometry around nitrogen and phosphorus respectively are. This is an old question, and this is a molecule, talking about the molecule. If you look at this molecule looks like this one, this structure. This is the structure of N3P3F6. So with respect to N, this is 2 bond pair, 1 lone pair, total n hybridization sp2, and this is square planar. With respect to p, 2 bond pair, 4 bond pair are there. So 4 bond pair means sp3 hybridize, so that is tetrahedral. So with respect to nitrogen, this is planar, and with respect to phosphorus, this is tetrahedral. So option no n, this is one lone pair is there, so 2 bond pair, 1 lone pair. So nitrogen is pyramidal and tetrahedral structure. Then moving on the next question, based on theory, predict the shape of xenon F5 minus and Br F minus respectively are. So these things you can calculate easily from the formula. So xenon F5 minus 5 bond pair, 2 lone pair. So this is pentagonal planar. For Br F5, so we have 5 bond pair, 1 lone pair. So this is square pyramidal shape. Next question, among ClO3 minus xenon O3 SO3 species with pyramidal shape is and are. So 3 molecules, maybe 1 molecule or 2 molecules, or all the 3 molecules are pyramidal or not. So let's discuss the shape of individual molecules. So this is ClO3 minus, having 3 bond pair, 1 lone pair, so that is trigonal pyramidal. In case of xenon O3, 3 bond pair, 1 lone pair, that is trigonal pyramidal. In case of SO3, 3 bond pair, 0 lone pair, trigonal planar. So we have 2 trigonal pyramidal shape, that is ClO3 minus xenon O3. So option number A is the correct answer. Moving to the next question, geometry of SnF3, xenon F2O2 respectively. So here xenon F2O2 can be calculated. This is the different SnF3. So here you have to see that sulfur is the nitrogen, sulfur is the central atom, SnF3. In case of SnF3, sulfur is the central atom, nitrogen one surrounding atom, and 3 fluorine another 3 surrounding atom. So total surrounding atom 4. So total bond pair of electrons 4. Half 6 is the outermost electron of sulfur, 6, minus 3 into 1 valency of fluorine, minus 1 into 3 is the valency of nitrogen. So we'll get 4 bond pair, 0 lone pair, so tetrahedral. So this is the structure of SnF3 tetrahedral geometry. Already we have discussed about xenon F2O2. So in this case we have 4 bond pair, 1 lone pair of electron, total 5. So the structure will be, basic structure will be trigonal bipyramidal. So this is talking about trigonal bipyramidal. So we have the option number 4 is the right answer. So fourth one is the right answer. So sometimes it is asking about the regular geometry, sometimes it is asking about the sub geometry. Means suppose you have a total bond pair of 5 and lone pair 0, that can be 5 means trigonal bipyramidal. Suppose 4 1 3 2, these are when the bond pair lone pair are breaking with each other or sharing with each other, then the substructures are come into the picture. Okay, then we will go to the another question. According to Bend's rule, for p block elements, the correct combination of geometry around the central atom and position of more electronegativity substituents are. So, in case of trigonal pyramidal, 3 fluorine will be there on its axial position, that will be higher electronegativity will be there. So option 1 is the correct answer. So these are only presence of fluorine atom gives the dipole moment at the axial position. So we'll talk about the shape of tellurium F5 minus. Tellurium comes under oxygen family, oxygen, sulfur, selenium, tellurium. So central atom tellurium, 5 fluorine atoms are surrounding atom, minus is the charge on the molecule. So we'll get 2 is the right answer. Okay. And how will get this answer? By calculating the number of bond pair and lone pair of electrons. So we'll get 5 bond pair of electrons, 1 lone pair of electron. So that is square pyramidal. Then if we will talk about another question, that is geometry of Br3 plus I5 minus. Already we have discussed about Br3 plus. So Br3 plus is nothing but tetrahedral geometry. We can divide Br3 into Br and Br2 plus. So we'll get 2 bond pair, 2 lone pair of electron, that is tetrahedral. In case of I5 plus, in the same way, one will be central atom, another 4 will be surrounding atom. So that will be I4 plus. So if we calculate the number of bond pair, lone pair, that will be 4 bond pair and 1 lone pair, and the shape will be trigonal bipyramidal. Okay, that will be diagonal bipyramidal. Okay, the option number 2 is the correct answer for this question. If we move to the next question, xenon F2, xenon O2 F2. So this gives, as you know, xenon F2 is linear and xenon O2 F2 is seesaw. So option number 3 is the right answer. Moving to the next question. Number of lone pairs of electrons on central atom in BrF4 minus xenon F6 SbCl63. So asking about the lone pair, how many lone pairs are present in this molecule? If we talk about BrF4 minus, total number of lone pair 2. If we talk about xenon F6, lone pair, number of lone pair 1. If we talk as SbCl6, antimony, nitrogen, phosphorus, arsenic, antimony, nitrogen family, so central atom as antimony, like nitrogen, number of outermost electron 5. So in case of SbCl63 minus, also number of lone pair 1. So 2, 1, 1. So option number 3 is the right answer. Option number 3 is the right answer. Sorry, in option number 3, option number 3 is the right answer. This is wrongly written, answer number 1. Answer number 3 is the right answer. So moving to the next question. The correct nonlinear and isostructural pair is. So listen, we have to toss again isostructural having same shape. Nonlinear means there will be no linear molecule will be there. As you know, I3 minus is the linear, so option number A eliminated out. We will talk about other structure. I3 plus is tetrahedral. Okay, let's discuss the molecules. So I3 plus, as you know, like Br3 plus, this is a 2 plus 2, 2 bond pair, 2 lone pair. We can say tetrahedral, we can say bent. I3 minus 2 bond pair, 3 lone pair, that is linear. If we'll talk about SCl2, S oxygen family, so like oxygen, sulfur is the central atom. So 6 number of outermost electron present. So we'll get a 2 bond pair, 2 lone pair. And again this is bent. If we'll talk about ClF2 minus, 2 bond pair, 3 lone pair, this is a linear. So which pair are non-linear? Linear. I3 minus ClF2 minus the option C cancel, D cancel. So B is the right answer. Okay, B is the right answer. So listen, next we will talk about number of lone pairs are identical in the pairs. Number of lone pairs are identical in the pair in which two pair of molecules having same number of lone pairs. So we'll discuss about the shape of the molecule and number of bond pairs and lone pair of electron present in this molecule. In xenon F4, 4 bond pair, 2 lone pair. In case of ClF3, 3 bond pair, 2 lone pair. So in case of ICl4 minus, 4 bond pair, 2 lone pair. In case of xenon O4, 4 bond pair, 0 lone pair. In case of xenon O2F2, we have 4 bond pair, 1 lone pair. So in case of xenon F4 and ClF3, same number of lone pair of electrons. Also in case of ICl4 minus. So correct answer is A. A is the or 1 is the correct answer. Then we will move to the another question. According to VSEPR Theory geometry, around center I3 minus, I3 plus, like Br3 plus, Br3 minus. Same. One is tetrahedral, another will be trigonal pyramidal. So in case of B3 plus, B3 minus, this will be the answer. The answer will be C. C is the correct answer. So if we will talk about another question, total number of lone pairs present in a lone pair of electron present in I3 minus, very simple. 2 plus 3, 3 lone pair of electrons present in I3 minus. Structure is linear. So answer number B. Then we will move to the another question. Which ones among CO3 2 minus, SO3, xenon O3, NO3 minus and NO3 minus have planar structure? Which three are planar structure? So if we will talk about CO3 2 minus, this is trigonal planar, and NO3 minus is trigonal planar again. Xenon O3 is pyramidal structure and SO3 is trigonal planar. Means except xenon O3, all are planar structure from the number of bond pairs and lone pair of electrons. So which pair xenon O3 cutting A is cutting B is cutting C cutting D is the correct answer. So D is the correct answer for this question. And moving to the next question. Among SF4, BF4 minus, xenon F4, ICl4 minus, number of species having 2 lone pair of electrons. In how number of species? So among 4, how many species are bearing 2 lone pairs? So for that you have to calculate the number of bond pair of electrons and lone pair of electrons present in individual molecules. So in SF4 we have 1 lone pair, in BrF4 minus we have 2 lone pair, in xenon F4 we have again 2 lone pair, in ICl4 minus we have 2 lone pair. So how many 2 lone pairs are there? In 3 molecules contains 2 lone pair of electrons. So answer number 3 question answer. So 3 the number of species. So B is the correct answer. The answer is wrongly written here. Answer B is the correct answer. Okay. So if we move to the another question, according to VSEPR theory, the molecule ion having ideal tetrahedral. So which molecule have ideal tetrahedral shape? So if we look at the structure of individual molecule in SF4, this is T shape. In SO sulfate ion, we have regular tetrahedral shape. In case of S2Cl2, this is a linked molecule having two lone pair of electron, two bond pair of electrons. So this is a bent structure. In case of SO2Cl2, that is 4 plus 0 tetrahedral, but SO4 2 minus is having ideal tetrahedral structure. In case of SO2Cl2, oxygen is a divalency molecule, so we'll take sulfate 2 minus as regular tetrahedral shape. So answer B is the correct answer. Then the molecule with highest number of lone pairs has a linear shape based on the BSA. The molecule with highest, which molecule have highest lone pair and also have linear structure. So we have to discuss about the shape of all these molecules. So carbon dioxide is linear but having zero lone pair of I3 minus is linear having 3 lone pair of so in other case we have 1 and 0 lone pair. So in case of I3 minus we have 3 lone pair of electrons. So answer B is the correct answer. Then moving to the another and last question of this video, among the following pairs, those in which both species have similar structure are which two species has similar structure? N3 minus, xenon F2, ICl4 minus, platinum Cl4 2 minus, ClF2 plus, ICl, etc. So we have to discuss the structure of all these molecules. So these are the in case of N3 minus, as we have discussed earlier, this is linear, xenon F2 also linear, ICl4 minus square planar, platinum Cl4 2 minus DsP2 square planar, that is from VBT, ClF2 plus, that is bent, ICl2 minus linear. As you know, xenon O3 trigonal pyramidal, SO3 is a trigonal planar. So which two species have equal structure? Listen, we have N3 minus xenon O. So A is there. So A everywhere, D is cutting, A, B, C. Again another square planar, so ICl4 minus, platinum B. So A, B. In case of C, not similar. So A and B only. So option number A is the right answer for this question.